Hello, I'm Kelly. Today I'm going to be giving a lesson in the product of prime factors, which is about GCSE level, maybe slightly lower maths. Usually I'd start my lesson by asking my student, have they done this before in school? You know, they may have covered it a little, they may have covered it a lot. We want to see where they're at already with the topic. And then I'd let my student know that if they have any questions at any point, they can always stop me and ask me them. It's a great thing about a tutoring lesson rather than a classroom, is that you really can stop and ask questions whenever you really need to. So then we get started with product of prime factors. To begin any lesson, I usually start with a bit of a recap over any information that the student would already have but might need a bit of a refresher on. So since we're doing the product of prime factors, we'll start by refreshing what are factors. So factors are numbers that multiply together to make a bigger number. So which sounds very confusing, but when you look at an example, it gets a lot easier. So if we took an example of, say, 6, what numbers multiply together to make 6? Well, we have 1 and 6 multiply together to make 6, and we also have 2 and 3 multiply together to make 6. And this means that 1, 6, 2, and 3 are all factors of 6, because 6 can be divided by them. If we divide 6 by 3, we'll get a whole number. If we divide 6 by 6, we'll also get a whole number, and this makes them all factors. The great thing about factors that we need to remember is that they usually come in pairs that multiply together to make the whole number. So if we look at our example over here of 20, if we multiply together 5 and 4, we'll get 20. So we can sort of find out pairs of numbers this way. If we divided 20 by 5 and it gave us a whole number, we'd know that 5 was a factor. But if we divided 20 by 5, it would also give us an answer of 4, and that lets us know that 4 is also a factor. The same here, if we look at 2 and 10. If we divide 20 by 10, then we get the answer of 2. And that means that both 10 and 2 are going to be factors of 20. We also have an interesting thing with factors, is that factors, any number other than 1 will always have at least 2 factors, and those 2 factors will always be 1 and itself. No matter what the number, you will always be able to divide it by itself and get an answer of 1. Whether it's 360 divided by 360, it's going to be 1, and that means that 1 is also always going to be a factor. This leads us on to a really interesting set of numbers called prime numbers. So prime numbers over here are numbers that can only have 2 factors. So we can have 2 or 3 or 5, but the rule is that they'll only have 2 factors, and those 2 factors will always be 1 and itself. So if we looked at 2, we can divide 2 into 2 times 1. So that gives us 2 factors. If we look at 7, we can divide 7 into 7 and 1. But we don't have any other numbers that go into it. We can't divide 7 by 3 or by 2. And that's really interesting, because that means we can create this whole set of numbers that don't have any easy numbers to divide it by except for 1 in itself. Now, we have an exception to this, a very unique number, and that is the number 1. Now, the thing about 1, and the reason it's not a prime number, even though it kind of looks like it should be, is because it can only be divided by 1. That means it's divisible by 1 and itself, but they're the same thing. So it only has 1 factor. That makes it not a prime number, but it does make it a very interesting case. So, what are a product of prime factors? Well, firstly, what is the product? So, as you'll remember, probably from BidMath and stuff like that, the product just means to multiply something together. So writing something as a product of prime factors just means writing something as a number of prime factors multiplied together. That makes it sound a lot simpler, doesn't it? So if we were writing 6 as a product of prime factors, first thing we want to do is figure out what are the factors of 6. So we've done this before up here already. So we know that the factors of 6 are going to be 1, 6, 2, and 3. So which of these are prime? Well, we've seen before from our special cases that 1 is not going to be prime. We also know, looking at this, that 6 isn't prime because we've got more than 2 factors written here. But we do know that from our prime numbers list that both 3 and 2 are prime. So we can write 6 as a product of 3 times 2. And that's what we've got down here. Now, what about 15? Again, let's write out the factors of 15. So we've got 1, 15, 3, and 5. Now again, let's go through the list. We know that 1 isn't prime because we've seen its special case up here. 1 has 1 factor. Now we can look at this and we know that 15 is also not prime because we've got more than 2 factors written around here. But from our list of prime numbers, we know that 5 is prime and 3 is prime. So we can write 15 as a product of 3 times 5, which is great. So that's really useful when we're doing smaller numbers because it's quite simple to break it down. But what happens when we get bigger numbers or more complicated numbers? We need a method, a routine or an approach in order to find these prime factors that make up a number. And to do this, we use a tree diagram. So a tree diagram has many different purposes, and this is only one of them. But what we're essentially going to do is we start with our number, and then on each step of the tree, we break this number down into sets of prime factors that eventually multiply together to create our number. So let's start with 12. First, we want to find the factor pairs for 12. So we have 12. We know that one factor pair will be 1 and 12. And we have another pair that's going to be 3 and 4. Now, one thing we want to know when we're drawing these tree diagrams is we always want to pick the number that is not a 1 or the number itself. The reason for this will become clearer as we go on, but if we kept picking 1 and 12, we could infinitely pick 1 and 12 and never get to a smaller number. We'd just keep going 1 and 12, 1 and 12, 1 and 12, and then we'd never find a prime. So we always want to pick the number that isn't paired with a 1 or itself. So here we're going to go with 3 and 4. We write 3 and 4 as our first level on the tree. Now, we've gotten really lucky here because already we found a prime factor. Here we have a 3. So we can stop with this trunk of the tree and just focus on the other one. So now we have a 4. We want to break this down into into a factor pair. So what are our factors of 4? Well, we could have 1 and 4, but as we've seen before, we don't really want to pick something with a 1 in it because we just end up doing the same number again. So what other factor pair do we have? Well, we have 2 and 2. So let's try 2 and 2. And then we end up with 3 prime numbers at the bottom of our tree, and we can stop. And that's the end of our tree. And now we get to write it as a product of those prime factors. So we can now say that 12 equals 2 times 2 times 3. Now we can always make this much simpler to read. So we can write 12 equals 2 squared times 3. It says exactly the same thing, but writing it using indices makes it a lot clearer. So now, usually what I do is I go through some more examples. We get more tricky example to go through. And then we have the solutions written out so that for my student, if they're struggling to read the handwriting, they have something that's much clearer to go back and reference. And then it's their turn to give it a go. I'll usually let them go through and give it a go completely on their own at first and see how it goes. If they have questions or want to ask anything, then they can, but it's up to them to try and see what they can remember. Then I'll go through it with them. We'll take it step by step and help them to identify where they've gone wrong. Finally, we'll move on to quite a few more examples to really cement what they've learnt. Then, after every lesson, I usually give my students a homework sheet. This will include questions very similar to the ones that we've covered in our class, and it will also include some questions targeted specifically at the areas they struggled with so that they can really cement their learning there. And that's about it. thank you for watching.